trying to stay cool on the hot days of summer. Hey, welcome to Weatherwise. I'm Fox 6 Chief Meteorologist Vince Condella. Early July, and it's hot and humid. But here's what's interesting. Every year in early July, the Earth and the Sun are at their farthest distance from each other in the orbit that the Earth takes around the Sun. How can that be? How can it be so hot during our summer, and yet the Earth and the Sun are as far apart as they'll be all year long? It's one of those great paradoxes of nature. Follow me and I'll explain. Inside the cool air of Studio A might be a great place to explain this, but I do need some help. So, I want to introduce to you the Sun and the Earth. The Sun in this case being played by one of our Fox 6 weather interns for the summer of 2011, Chris Scheele. And the Earth being played by another Fox 6 weather intern for the summer of 2011, Stephanie Lein. Now, in order to get a perspective of how the Sun and the Earth relate to each other this time of year, we need to go up to a little higher perspective. Follow me. From this perspective, we can use our imagination as we look down on the Earth and the Sun. Remember, the Earth does not orbit in a perfect circle. So with an elliptical orbit, at one point the Earth is at its very farthest from the Sun, and at another point it's at its closest. Well, let's stop at the closest. That is called perihelion. And that occurs usually around January 3rd or 4th every year. The Sun and the Earth are only 91.5 million miles apart. That seems odd. Here the Sun and the Earth are as close as they're going to get all year, and yet it's in the middle of our winter. But what about 6 months later? Well, let's go to the other part of the elliptical orbit, and here the Earth and the Sun are at their farthest point from each other, and that's called aphelion. 94.5 million miles away. But that doesn't make any sense either. How can the Earth and the Sun be at their farthest point and yet it's so hot around here during the summer? So, the difference in the seasons has nothing to do with the distance between the Earth and the Sun. Instead, our seasons have to do with the tilt of the Earth on its axis. For example, during the summertime, our hemisphere, the northern hemisphere, is tilted towards the Sun. Our solar radiation is more direct as the Sun is higher in the sky. But during the wintertime, our hemisphere is tilted away from the Sun. There's a lower sun angle. We get less direct solar radiation and therefore less heating. So keep in mind, during aphelion, this time of year, when the Earth is at its greatest distance from the Sun, our hemisphere is tilted towards the Sun, and therefore, despite the far distance from the Sun, we still get more direct solar radiation. That's it for Weatherwise. We'll see you on Fox 6 News.